Okay, so in the next part of our pretest, problem 3, 4, 5, and then problem 6, right, which is, I believe, on the next page. All of these are basically R3 material. All right, so for more practice and so more review, what we're going to be looking at is R3. All right, and so with that in mind, what we're going to be talking about in this chapter is we're going to be talking about polynomials. And so there's a lot of lingo, there's a lot of ideas. I usually find that polynomials are pretty much essential, but oops, you know what? I made a mistake. I'm sorry, R4. So R4 is where we review polynomials, okay? Better read my own notes. Sorry about that. All right, so let's go ahead and get down to business. So in the first example, I'm asking you to create one polynomial and that satisfies all of the following conditions. So we can definitely probably find one polynomial for each, but the polynomial I'm trying to create has all three things. So the first thing is a trinomial. All right, so there's basically, that means that there's three terms in it. Its degree is 3. So that tells me that the lead coefficient, the leading term, has to be x cubed. So to get any other term, you can write down pretty much whatever you want. So I'm just going to simply write x squared plus x. So right now what I have are two conditions met. I have a trinomial, there's 3 terms, and its degree is 3 because that's the highest degree term in the problem. But the last one is that the lead coefficient is 5. So the lead coefficient always goes with the highest degree term, so that means that the lead coefficient, the number part of that term, would have to be 5. And so there's a potential answer there. There's actually an infinite number of answers as long as the leading term is 5x cubed. We can pretty much write down whatever we want. Right, so here's another one, 5x cubed plus 3x plus 7, or if you like, 5x cubed minus 2x squared, minus 1. All right, so we can even do some subtractions in there. So there's a lot of right answers there. Each one of these is a trinomial. It's of degree 3, the highest degree on all my terms, and the lead coefficient, the number part of the highest degree term, right, is 5. So multiple answers for number 3 there. Part 4, again, I have to create one polynomial that could be called the difference of cubes. All right, so what I'm talking about there is, first of all, we're talking about a difference. So we have to be talking about something that is a subtraction statement. What are we subtracting? Or we're subtracting 2 cubes. So one example would be something like x cubed minus y cubed. I'm subtracting cubes. So there would be a difference of cubes. Of course, there's many other answers, right? Because we could also have x cubed minus 27. That's also a potential answer because the first part is the term 2x being cubed, and the second part is 3 being cubed. So I have the difference of 2 things being cubed. Of course, I'm pretty sure as you're sitting there at home and watching this, you can come up with so many more. So I only asked for one. So there's a potential answer. There's a potential answer. We're talking about a difference, a subtraction of 2 things being cubed. All right, so some good terminology there. Adding and subtracting, right, part 5. Well, in order to add and subtract polynomials, all we basically have to do is combine like terms. That's basically what's going on. So combining like terms. So here what I have is I have a trinomial of degree 2, and I'm adding it to another trinomial of degree 3. So because we're adding, the parentheses here are just being used to distinguish one trinomial from the other. So I can pretty much drop the parentheses. And then we just start mixing and matching. So here's the only term with x cubed in it, so it does not combine with anything else. Here's the only term with x squared in it, so it doesn't combine with anybody else. And then I have a minus 3x and a minus 4x. So those guys combine up to negative 7x. And then we have a plus 4 and a minus 5. Those will combine up to minus 1. So the result of that addition would basically be a quadnomial, right? A 4-term polynomial of degree 3. X cubed plus 2x squared minus 7x minus 1. All right, so hopefully that's a decent review of adding polynomials. Subtracting is very similar, but we have to do one thing first. So I've got this trinomial, and I'm subtracting this trinomial. That subtraction basically creates an opposite in all the terms behind it. So when I go back through and I drop my parentheses, I essentially have to distribute that minus sign. Of course, when I distribute that minus, what it causes is a change in signs. So what used to be a positive 2x squared is now a minus. What used to be a minus 3x is a plus. What used to be a plus 4 is now a minus. So a sign change occurred. And then we're back to combining like terms. So there's a term with x squared, and here's a term with x squared, right? That gives us a negative x squared. Here's a term with x, and there's another term with x. So minus 2 plus 3 leaves us with just 1x. And then we have plus 5 minus 4, leaving us with plus 1. And so there would be our final answer for that subtraction statement. Okay? So again, I was wrong about the thing. For more practice, to get more in tune with this, right, we're looking at R4 in your review homework on my math lab. And then, of course, now that we know how to add and subtract, right, the next idea is how do we multiply? All right, let me get this next guy up here. So the way that we would multiply is effectively what we call distribution. All right, and we do this distribution term by term. So the first one's pretty easy to look at because I only have one term, right, a monomial being multiplied to a trinomial. So in effect, we're going to basically multiply that one term. We're going to distribute it, right, to the trinomial. So when I distribute here, a negative 3 times a positive 3 is a negative 9. X cubed and x squared, well, I would add exponents there, giving me x to the 5th. A negative times a negative is a positive. 3 times 5 is 15. X cubed times x, well, adding exponents again, we will get x to the 4th. And then last but not least, a negative times a positive is a negative. 3 times 2 is 6. And then we have an x cubed. So there would be our multiplication, all right, for letter A. For letter B, a little bit more going on. We have a binomial times a binomial. You guys classically know this as FOIL. But again, it's just term by term multiplication. I'm taking the first term, right, 4x times 5x, that's the f, so that gives us 20x squared. I'm taking the outer term, so that would be that route, giving us a negative 8x. I'm taking the inner terms, right, so that would be the inner, giving us a positive 5x, and then I would do the last. Well, 1 times negative 2 gives us minus 2. So FOIL, first terms being multiplied, outer terms, inner terms, last terms. We're basically term by term distribution. All right, that's basically what multiplication is all about. To finish this one off, we notice that these two terms are like. So I'll combine like terms, and that would be my final answer for letter B. Okay, letter C, you got to be careful. It's a classic mistake to take this 2 and apply it to both. That does not happen here. What we get is 2x plus 1 times 2x plus 1. That's what it literally means to square a sum. You're multiplying it to itself. And now, of course, now that I have that, we're back to the good old FOIL term by term distribution. So when I do the first, we get a 4x squared. When I do the outer, I get a 2x. When I do the inner, I get a 2x. When I do the last, I get a positive 1. So we end up with 4x squared plus 4x plus 1. So make sure, be careful, there is no rule for a power of a sum, right? What we do is we break it up and then we FOIL it out. And then the last multiplication that we got here, right, what we have is a binomial times a tri. Well, again, we're distributing term by term. So first I'll do the 2x. 2x times 4x squared gives us an 8x cubed. 2x times a negative 6x gives us a negative 12x squared. A 2x times a 9 gives us an 18x. And so we're done with the 2x. Now we distribute the 3. So 3 times a 4x squared would give us a positive 12x squared. A 3 times a negative 6 is a negative 18x. And then a 3 times a 9 gives us a positive 27. Excuse the cough there. And so there's basically the multiplication. We're term by term distributing basically. And now to finish this one off, we basically have to combine like terms. And there's a negative 12x squared and a positive 12x squared, so that's cancel out. An 18x minus an 18x cancels out. And we're left with an 8x cubed plus 27. So there's the multiplication. And the last thing I will say about this is this can actually be thought of as the sum of cubes, right? Because we basically have 2x cubed and 3 cubed. So in relation to our difference of cubes earlier. All right, so that should wrap up our polynomial discussion. Again, for more practice of these ideas, you're looking at R.4 in your My Math Lab homework. All right, so more later as we move on.